right, so here's a little person on a sled with a scarf. That's what that is right there. So we're going to give him a little track. Okay, so and I always forget how to undo it. That'd be good. I think I'm not gonna do that. Well, what do you think that is?
Oh, press the thing button where you track. Where is it? Oh, press the button, the one at the top right, top left. No, all the way to the top left. Yeah, that page folder. It's a new track.
Thank you. That's going to be extremely helpful. As many times as I've done that, I can't do it. All right. I think I can move. No, I can't move. All right. So, oh, there you just went.
Oh, that's Steve.
Oh, no.
Infinity!
Negative infinity. All right. All right. And at least one more.
Can we make them in a circle?
Don't get me started. I'll get way carried away. But you can play with it later. It's linewriter.com.
Do a big wall that it goes. Can we make him jump?
I've had students that can do incredible things with this. That I'm wondering if, like, maybe you didn't have your homework ready. But it is really fun. We'll go up a little hill and down a little hill. I don't know if I gave him enough momentum.
You already know that about the words. You can't believe that actually happened in my life. No, it's just like you don't seem like a pottery person. You seem like go. This is not live, guys. I'd be so sorry. Back at it again.
Let's see.
Erase it right now. Just erase.
Need to get more momentum.
That I want them to know. Yes.
All right, why do you think I did this one?
Oh! Oh my God! You just impaled him.
That one's supposed to happen. What was supposed to happen was that you just saw the little line writer, just it had a hole in the graph, but at first it didn't matter. I didn't realize that it was going to back up and like do that. But there's like a real story that I'm going to compare that to too, and then we'll move on and do real problems. I just want you to really think about the logical concept here. All right, so here's a river, okay? I was actually in Shreveport, Louisiana, trying to get to Jackson, Mississippi. And I was riding in my car, my Jeep. I had a really cool Jeep Wrangler. I was riding in my Jeep. People were babysitting my kids till I got home, okay? And as I got closer, I got a phone call, like my mom had heard that the bridge over the river was out, that there'd been an accident or something had happened on the bridge and they weren't letting people over. And here's my house, okay, and here's me. And sure enough, I saw like highway patrolmen and policemen stopping people and diverting traffic, and we could not go over the bridge. So, granted, I had a Jeep Wrangler, but it still could not like ford that river. Okay. So anyway, I had to go. They were directing us this way. Meanwhile, I found out people coming from this direction couldn't get to Louisiana, but instead of sending them this way, they sent them this way because we all had to go looking, and it got kind of precarious. It wasn't a horrible disaster, but some of us were running out of gas because that's a 3-hour trip from here to here too. It was a 2-hour trip from, I was in Shreveport, not Monroe. You don't care. Say it was a 3-hour trip, okay? And then all of a sudden, I have to drive down to Natchez, Mississippi, was the next bridge over the river. These people are driving up to Memphis, Tennessee, which is about a 3-hour drive, before you could ever even find a bridge and go across the river and then come back down to go where you wanted to go. So it turned into an 8-hour trip for me that day. But you're in this long line of cars. People are hot and mad and confused, and everybody's trying to, make phone calls and get everything squared away, late to work, can't pick up the kid, blah, blah, blah. So do y'all see how the bridge was out? The bridge is out as like a vertical asymptote. You are not going over it, okay? It's a river. So a crane had fallen and it didn't destroy the bridge, but it was non-operational for a while, a week or two. So it's very inconvenient. But you see how we're going like this, and there's a river, and there's no bridge, and so it's discontinuous, isn't it? I could put the bridge back, and then everything would be fine. But it was not defined there, and so we went like this. Another true story. I don't have a car anymore that I live in the city, but let's say here's my house, okay, and the school that I taught at the time, let's say it was over here. Okay, it wasn't that far away. Now it's not drawn to scale, but again, you don't care. All right, so I'm driving to school, and our roads were famous for potholes. Do you know what that is? So there was a pothole, and I went on to school. Okay, there was like a little orange cone in the road to warn us about the pothole. Okay, the first scenario. By the time I picked up my kids and got to work, I didn't even make it to work. The next day, that was a big story. Oh my gosh, I heard the bridge was out on the way back from, Louisiana. And, where'd you get across it? It was a whole, I told it over and over again. What happened? I mean, if I'd gotten to school the next day and said, I had to go around the pothole. I wouldn't even say it. Do y'all know what I mean? It's a non-event. It was just then I was at school. It was still a point of discontinuity. Do y'all see it was still discontinuous? I had to change my route a little bit, but I just kept on going. Okay? So, suppose that I take this cup that Miss O.D. gave me, so I'm not going to actually break it. But suppose I take this cup and I slam it against these marble things right here. It's going to be shattered. It's going to be unusable. It's going to be badly broken. That's undefined. Okay? This one doesn't actually have a chip on it, but a lot of my coffee cups do. Might have a little crack right here, or a break in the handle, or a chip down at the bottom where it's not leaking out. You all know what I'm talking about. And you have many things that have a chip or a tear or something. Well, now tears are intentional in your clothes, but you have something that you keep on wearing that until you have time to fix it, or you like it, or whatever. So it's not unusual. I'm not going to throw it away. It's fully functional. Do y'all see what I mean? Okay. So do you see the difference then? All right. One, I can just keep on going with my life. The other one is I gotta go buy a new coffee cup. Okay? All right, so now let's do a problem, now that we've done all that fun stuff. But I do think it's good to see, really good examples of things. Why is that not doing? It was working a second ago. It works down here. There. Okay. Will someone read me number 1? 1 over x plus 2. Okay. You will notice that I like technology a lot, a whole lot, and I use it a lot. But here I'm not going to use it for rational functions until I already know what I'm expecting to see on my calculator. Notice when and how I use my calculator. Okay. So I'm going to go on and start pulling it up. And I promise you this. If you think you're going to come into a quiz or a test, anyway, I've got a graphing calculator. People actually say that to me all the time. I mean, oh, they can teach math, but now they have those fancy calculators, and they don't have to do anything. I think you all know from your homework that if you came in to my test on rational functions and thought that you were going to pass it just by using your calculator, you're probably going to fail it if you're just copying the pictures off your calculator. I think a lot of you suspect those pictures aren't really right, by the questions that I've had. And if you don't suspect it, let me tell you, the pictures aren't really right. We can make them right based on our own knowledge in our head. Okay, so you're not going to trust your calculator. So wake up if you thought you were going to trust your calculator, because all of a sudden you're like, oh my gosh, I got to listen. All right, so I look at this and I can't help but notice that this is undefined at -2. Then I quickly fill it in the numerator to make sure I don't have a 0 over 0 and be suspicious of a subtle discontinuity. This one, I hope the calculator's still there somewhere. Do y'all see the icon for it? Did I just close it accidentally?
No, it's on Google Chrome. Where it'll be trash on the bottom. Oh no, never mind.
Sorry, it's worth me opening it because you're going to have all these questions. Apparently, I've got some little picture there. Okay. So my vertical asymptote, I always look for that first, by the way, is where it's undefined. If you get 0 over 0, it is not a VA. Do not call it that. Don't call it a whole and a vertical asymptote. It's either badly broken and I can't put coffee in it, or it's not, okay? So if you get 0 over 0, there is no vertical asymptote. There's probably a whole, but not for sure. I'm not going to take a lot of questions right now, so write down your question. I'm going to take Lindsay's, but write down your questions, okay?
So can it only be 0 for 0 if like there's at least an x on the top?
Got to have a variable in the top for that to happen. Okay, so I have a vertical asymptote at x equals -2 because right now I'm getting 1 over 0. You have to say x equals what makes the bottom 0, okay? There is no hole in the graph. If I was checking for a hole, there's not a hole. I don't run into the possibility of a hole. Does it have a horizontal asymptote? I'm going to just go through the list of things that we check, and you'll see on the worksheet that that'll help guide you through it. It has a horizontal asymptote because it's heavy on the bottom. To be a little more, what I mean heavy on the bottom, the top doesn't even have a variable. It's a constant over something that's varying. As I feel, okay, my arms, I did this the other day. I'll continue to do it. I'll do it for a year or two for some of you that have me for BC. But this is a horizontal asymptote, right? But what are my arms actually going to also? Infinity and negative. We're pulling away and looking at the corn maze from the air, okay? When you're doing a horizontal asymptote, you're saying, is there any kind of form of end behavior that's linear right now? So you think to yourself, what if I put in huge numbers? What if I have one cookie and thousands of people want a bite of it? This is going to go to what?
Negative, closer to 0.
It's going to get closer and closer to 0. So as these numbers get larger, horizontal asymptote, as I put in big numbers, this is going to go closer and closer to 0. 1 divided by a big number is going to be very, very what? Small. So you have to say y equals. This is something I haven't shown you yet. I just let you kind of fumble around in the dark. But when I come behind you now, you'll see why I teach the way that I do. It'll be clearer because you've really tried this really hard. I'm going to teach you today how to find out if it's going to cross the asymptote, okay? You can cross an asymptote. I'm not going to pull up more stuff. I give too many illustrations to try to make it make sense. But I'm looking at cars right now outside this window, watching them drive down the street. They're lines. They put asymptotes on the street for us, okay? And SUV, they're all gone now, but the SUV or the taxi, as they're coming down one lane, they might realize they need to turn right, and so they cross over the line for a minute to get in another lane, right? So you can cross the asymptote. I thought about races in the park. If you ever do a race, You can look up some of you that run probably looked up ahead of time the course map, maybe, and it's got this little like line that's going around the park that you're running in. You don't have to run right on that line, okay? It's a guideline. Could you run right on that line? Yeah, you could, okay? But you see, you're all going to be going that way. So it's a guideline. You don't want to be way over there in the woods. You know, somebody will go looking for you and get you back. Come back over here by the asymptote, okay? So, so you can cross it, but it's really good to know ahead of time if it's going to cross because it can make your life so much easier, okay? Let's use some logic. I'm about to graph this. Y'all know that, and I haven't done something I always do. As I'm finding this myself, I always draw as I find. X equals -2 is a vertical asymptote. Y equals 0 is a horizontal asymptote. Why are these dotted lines?
Because
They're not really there, right? Okay, they're just guidelines for us to follow. It's a pattern. Now I'm about to draw it. Which one of these asymptotes could it cross? Only the horizontal. It might come down here and go, I told you to stay on this course and you're going to get things back up to it at some point, but it could cross it. It's nice to know ahead of time if it crosses. So let's use some logic. When have you ever found out if two things cross? How do you find out if this equation is going to cross this equation? Exactly. Do you see how that has a y equals 1 over x plus 2 and a y equals 0? It's not anything you have to memorize. I really teach that you understand, I hope, instead of having to memorize. If you understand it, you don't have to memorize it. Okay? And I'm thinking, I want to know if when I start filling in x, if it's ever going to hit 0. Do you see how logical that is? I'm going, I wonder if this is ever going to hit 0. Okay? So I'm going to set them equal to each other. I'm going to check for cross. So I'm going to say, as I start filling in numbers, or as Katie said, do you see how I'm setting them equal to each other? Okay. And now I'm going to cross multiply, or multiply both sides by x plus 2. This cancels, and I get 1 equals 0. Does 1 equal 0? No. So this tells me conclusively it's not going to cross. If it ever was going to equal 0, it'll give you 1 or more x's where that happens. We'll do some. Okay? This one doesn't cross, so now I've got an easy problem. If it doesn't cross, I don't have to find many points. So let's find some points. Okay?
You would always tell if it crosses the horizontal asymptote
Or the slant. It can never cross the vertical.
by just equaling it.
Do you see how they're both equal to y? So you can set them equal to each other.
Okay.
You know how you've done in algebra 2, y equals x plus 2, does it cross x squared minus 4? You set them equal to each other.
Okay.
Okay? And so the safety net here is you couldn't set it to the vertical asymptote even if you tried, because one's equal to y and one's equal to x.
Say like they were equal to each other, then would it cross?
I'm not going to answer many questions.
Okay.
I'm going to keep on getting examples in front of you. Yes, yes. Most of the time, not always. All right, now I'm going to find a few points. I'm going to just make myself a little XY chart. Many times I don't write this down. I'm just doing it in my head like I did with you this morning, Nicole. We just did a few in our head. You can use your calculator at this point to find points. I probably would also do that, but these are pretty easy. If I fill in 0, 0 is always a good number if you can fill it in. I get 1/2. Because those of you that really know what you're doing, your graphs will all look the same. Grading your test will be easy, okay? Because you'll learn to get a few points and draw it to scale. I demand that your graphs are drawn to scale. Graph at least up to my graphs or better, okay? Don't ever give me a graph that doesn't have units marked off, ever, okay? If I'm your financial advisor and like my cousin is I made that sound like I have enough money for him to be my financial advisor, but the key word in there is my cousin is my financial advisor, so I don't have some big, anyway, I've got a little bit of money for retirement, like I'll never retire. But anyway, he sends a quarterly statement, so your parents also get one for their investments. But if it doesn't have any numbers on it or units of measurement, I have no idea what my money's done, right? If there's just this graph there, I don't have any idea what's going on. Does that make sense?
Yeah.
Always give me units of measure. You can make your units 5, 10, 15, 20, 1, 2, 3, 4. If you don't make them 1, 2, 3, 4, tell me on your graph you're counting by threes. Like you'll go 3 and put 3, 6, you'll put a 6. Okay? All right, let me keep going. If I put in like for instance, 3, I get 1/5, and I'm like kind of done with that. I realize it's getting closer to 0 this way. I'm going to fill in -1. If I fill in -1, I get 1. And now I know it doesn't cross the asymptote. So do you see I'm getting a really good picture? You'll see graphs where this piece is going to fit here or here in this pocket. Let's call this the pocket, okay? It's going to be here or here. There's something back there, by the way. Let that be a good lesson to you. Because what's the only place that this graph does not exist is -2. That means I don't care what your calculator tells you. It exists everywhere but that. Okay, so there's something back there. If you don't know where it is, you could go to table and ask table, right? You could go, where is it? And fill in -3. Okay? If I fill in -3, I get -1. And I could be doing this in my head or on my calculator. I would say, please don't look at the graph of this before you start. Get everything in place, go to table, resist the temptation to look at the graph, because then it can color your thinking about what you're doing. But freely use table and find some points real quickly, okay? If I fill in -3, I believe I get -1, do I? Yeah. I don't need many points over here because I know what's going on, because I really like asymptotes and it never crosses the graph. Okay? I'm going to go to another problem, even though you may not be ready. It'll help you. Okay, number, whatever the next one is. 19. Katie, you want to give it to me?
5 plus 2x over 1 plus x.
Okay. Vertical asymptote, I suspect is x equals -1. And if I fill in -1, I do not get 0 over 0. So there is no hole in this graph. Okay. It is a vertical asymptote. Horizontal asymptote, I cover up, I'll hit the undo button, but I cover up everything except for the highest powers of x that I can find. All that other stuff is just insignificant, because where am I going to with the horizontal asymptote? Okay, so if I have $500 billion, you go, wait, I'm going to give you $5 more. Doesn't matter, okay? If you gave me $5 right now today, I'd be ecstatic, but it doesn't matter, okay? So do you see those fade into insignificance as the graph goes, as you pull further out on the airplane, those maybe stalks of corn that were out of place become insignificant, okay? And so you're looking at the big picture. The horizontal asymptote is y equals 2. I'm going to check for cross. I know I'm going fast, but it will help. To check and see if it crosses, I set them equal to each other. So I take y equals 5 plus 2x over 1 plus x, and I set it equal to y equals what? 2. By the way, let me draw some things. My vertical asymptote is -1. My horizontal asymptote, this will hover close to 2. Actually, just cover up where I find my highest powers of x and reduce. And I'm going to check for cross. So now I'm going to cross multiply and get 5 plus 2x equals 2 plus 2x. What happens to my 2x's? Does 5 equal 2? Safety. I know it doesn't cross, so I'm relaxed. I can just put it in the little pockets. Once I find if I find a point up here, it rests in that pocket. If I find a point down here, it rests in this pocket. If it crosses, I got to figure out what in the world it's doing. Again, like we talked about, Nicole, like the swerviness. I think we know the answer to that after our conversation, but people would wonder that. All right, I'm going to find a few points. If I fill in 0, I get 5. And I would find a few more points if this was my test, but it basically goes like this. It's not my test. It's not my quiz. You find a couple of more points, okay? Now, I wonder what's back here, right? What's back there? There's got to be something back there because it's defined back there. So that's the biggest mistake some of my students do is they think just because they can't see it from -10 to 10 that there's nothing there. There's something there, okay? And who can you ask? Table. If I fill in -2, I get -1. Is that right? Oh, it's right here. If I fill in -3, I get 1/2. I hope I got those points right, but it looks like this. Without this dot's not there. A lot of you got that, I bet. Girls, I don't think it's going to happen in honors pre-cal, but sometimes you'll turn on your calculator and look at the graph, and you'll get, if it hadn't happened to you yet, it will. You'll get something that looks like that, kind of like a check mark. It's just because the pixels are having a hard time drawing the graph. Do not ever draw something like that for me on the test, okay? Or on a quiz. On your homework, it's up to you, but it'll happen where things look like they're joined and they're not. Oh, by the way, I hadn't even looked at any of these yet. But now if I looked at the graph, I'd probably be convinced that I had done it right. Okay? All right, now let's go to the next one. Will you call out the equation legally? Do you have it?
No, I don't.
Okay, you didn't write down the problems. Okay. This has two vertical asymptotes, most likely. Raise your hand if you want to give me the vertical asymptotes. Where is this undefined? Okay. Grace Hooper?
X equals 2 and X equals
Okay. Grace and I are going to double check and make sure it doesn't make the top 0. Make a quick check of the top. Okay? It doesn't make the top 0, so I'm going to put my, so there's no hole. You're still waiting for a hole. Okay? X equals 2, X equals negative 2. It's a very interesting graph. I have no idea what it looks like on my calculator, but I don't really care right now. All right, so now I'm going to look for horizontal asymptote. And I look at my highest powers of x, and I see x squared over x squared. So what's my horizontal asymptote? Y equals 1. Were you just going to answer the horizontal, or did you have a question?
I was going to answer.
Okay. Now, I want to know if it crosses this horizontal asymptote before I ever start graphing. If I remember, this is the one you and I talked about?
Yeah.
There's going to be a few students on this graph that are they're misbehaving a lot, okay? It'd be like if 17 of you are sitting there listening to every word and you're following the asymptote y equals 1, and a couple of y'all are turned around and got out your phone and, got up and got a game. There's going to be part of this graph. Now, eventually I'd try to pull you back to what you're supposed to be doing. By the way, if you do all of that, I'm not a great disciplinarian, so I don't have a plan. But anyway, just sit there and listen. I'm going to check and see if it crosses. So I'm going to take x squared over x squared minus 4 and set it equal to 1. I'm going to cross multiply. X squared equals x squared minus 4.
0.
Did I do that right? Oh, so this one doesn't cross.
No.
Okay. So this, does it have a little U shape in it?
Yeah.
Yeah.
It was the next one necessary, not this one.
Okay, good. They're great to compare. I get 0 equals negative 4. That doesn't happen, so this one does not cross. So I can relax and put it in a pocket. Okay, what do I mean by that? If it doesn't cross, if I fill in a number like 3 and I get a negative, it rests entirely down here. If it crosses, I have to figure out what's going on. Okay? So if I fill in 3, I get 9 over 5. So it's up here somewhere. Is that right? Is that what y'all got? If I fill in negative 3, I probably get something similar. I get the same thing. It has some symmetry. In fact, this graph is what we're going to call later in the year, or you heard it in Algebra 2, this graph is even. You may have wondered who cares, but I can look at f of x and f of negative x, and it makes it easier for me to graph that just goes. I'll go over it later. It's nice to know if it's even, odd, or neither. Yeah. So it's good to know. Anyway, you all learned it at some point. If I fill in 1, I get negative 1/3. And if I fill in negative 1, I get the same thing because of the symmetry. If I fill in 0, I get 0. So this thing must have looked like this. All right, and I hadn't even looked at it on my calculator. At some point, I would probably turn on my calculator on a quiz or test and look at the graph and go, okay, now that makes sense. But I already know what it should look like. You're really just verifying your results. If it doesn't look like that, then you go back and work on it some more. You might be frustrating to like change your window and see what you already know is there. Do you see how this part is misbehaving? But if I zoom out and zoom out, aren't these people going to fade into insignificance? Okay. So, it's similar to when you're talking to somebody and you've got like a club or a team or something like that, you go, everybody's so nice. We have such a good time. Everybody's there on time. Probably not completely true, right? But in the big picture, that is true. You're sitting there waiting. Now, there may be one person that straggles in late. There may be one person that posts pictures of you on, somewhere you don't want them, whatever. But do you see how you're looking at the big picture when you're doing that? Write your question down. All right, next problem, Katie Hall.
3x over x squared minus x minus 2.
Oh, interesting. Make sure I copy it down right. Okay. By the way, if you're going to put it in your calculator, you would do it in parentheses or use the cute little n over d thing, alpha y equals. And there's something else I was going to say. I don't know what it was. All right, so I factored the bottom. Hey, every polynomial won't factor. I'm going to tell you all your vertical asymptotes in my class and in calculus are not going to be at integers. Just right now they are. Do you foresee a time that something won't factor and you're going to still have to find what makes it 0? We'll usually do that with our calculators. There's a calc 0 button. So if it's not factoring, it just tells you if it's a nice fast 0 that you could have found. If I can't factor it, it doesn't mean there's not any zeros. It just means I'm going to have to go to step number 2. Okay? And we're not worried about that today. So this is x, 2, 1, minus plus. Sorry, I wrote that so little and so ugly. All right, I suspect my vertical asymptotes are x equals 2 and x equals negative 1. I'm going to do a quick check of the numerator. That was a question mark. And the top is not 0 either time. So those are vertical asymptotes at 2 and at negative 1. So there's no hole in the graph. I still haven't gotten a 0 over 0. My horizontal asymptote, are y'all okay with y equals 0? Raise your hand if you can tell me why my horizontal asymptote is y equals 0. Rebecca?
Because x squared is it's like bottom heavy.
Yes.
So x squared is like acting as a 1, and then there's no x squared at the top, so it's like 0 x squared, and 0 over 1 is 0.
Well, I think I would explain it a little bit differently. If I circle the highest powers of x, which you took us to, Rebecca, you have 3x over x squared. What reduces there? Don't the x's cancel out?
Yeah.
3x over x squared, if that's all I wrote, wouldn't you get 3 over x?
Yeah.
What's 3 cookies divided to 3 million people? You're going to get a little bit of crumb, right? So if you take a number and divide it by a heavier number, it's bottom heavy, which goes to 0. Okay? All right, which may be what you said. I may have just said it a different way. Now, how can I check for cross? So I'm going to say 0 equals 3x over x squared minus x minus 2. There's going to be times today before we leave that I factor and cancel. And I'll tell you what to set equal. If you cancel something, you're going to wonder, well, which one do I use? Okay? Now when I cross multiply, I get 0 equals 3x. And so what do I get?
X equals 0.
It's saying, I'm going to cross. I'm going to be bad. I'm going to hit the asymptote. Okay, well, that's not necessarily bad, but this is bad in this case. It's not wrong to be right on an asymptote. We're going to see some graphs where it's like if I said, oh, we've got a fire drill and follow me, okay, and I look behind me and you're pretty much behind me, as opposed to if I said follow me and I look behind me and y'all are being like super careful, like you're stepping in like every footprint that I make if it was like snow or wet on the ground. Y'all are all like, there's going to be some graphs that do that where you say follow me and they just say only asymptote. You saw one in your homework. You were probably maybe puzzled by it. All right, so now it crosses at 0. What do I mean it crosses at 0? That means that it hits the horizontal asymptote at 0. So I know I have this point right here.
Because you know the horizontal asymptote is at y equals 0. Wait, so it's like...
Remember you were checking to see if it crosses the asymptote.
Yeah.
And so your asymptote is at 0.
Oh, and it
crosses at 0.
So that's just
Yeah, it's kind of unfortunate. The first example I do both have a 0 in them. I wish this had said 1 and this had said 4. Then it would hit 1 and x is 4. It'll tell you everything. It will tell you. Algebra will tell you. Okay, now I've got to find some points. Oh, I want to say this. If it crosses more than once, it will show up here. okay? If it crosses more than once, it will show up here. It only crossed once because I did the math. So once I find the pocket, it's going to sit in it in the other places, okay? I'm going to fill in a few points. If I fill in 1, I think if I fill in 1, I get -3, if I did that right. So did it look sort of like this? Or did it go the other way?
It went that way.
Okay. Now I'm going to fill in a number after 2, like 3, even if I don't see it on my screen. And if I fill in 3, I get 9 over 9 minus 3 minus 2. 9 over 4. So it would be 2.25. So that means it sits in this pocket. On the test or quiz, I'd find a couple of more points. And then back here, if I fill in a number back there like -2, I get -6 over 4 plus 2 minus 2 negative. So this one I think sits in here. Do you see how fast I can move through that? Is that right? Did it look like your graph? Okay. All right, let's do next. All right, Katie.
X squared minus 1 over x plus 1.
Wow, if you graph that one, you see this. It's very surprising. You're like, I thought I was studying rational functions, okay? So let's start with what we think is a vertical asymptote. I think my vertical asymptote is -1. Oh, but if I check the top, what do I get? Well, I suspect. It's not a vertical asymptote. If you get 0 over 0, don't leave that sitting there. Go cross it out. You don't have to erase it. Just go, nope, it's not. I thought it was, but it's not. I mean, I didn't really think it was, so don't worry about me. But you know what I mean. All right, so I think that it's a hole in the graph. And up to now, you haven't seen anything different. I'm not going to right now give you anything different until I show you something that's not a hole in the graph. That's also not an asymptote, okay? So, but it's out there. All right, so I think there's a hole in the graph at where? At -1. Okay, the biggest question is where to find the hole in the graph. Like, how do I find it? There's a few options. All right, here's kind of a little bit of bad news, or interesting news. What all of us math teachers have said to you in the past is a little bit incorrect. You'll hear that in pre-cal. You'll go, what? And of course, I was maybe your algebra teacher, so I'm not pointing the finger at anybody else, because they'll go, but you did that. And it's so we can keep moving and lay the foundation, but now we're in the nitty-gritty of you got to really understand. If I factor this out, I get x plus 1, x minus 1 over x plus 1.
The x plus 1 and x plus 1.
Yes, but your math teachers, including myself, let that little equal sit in there. Those aren't really equal. Those are two different graphs. Let me show you. Which results in that look on everybody's face, like, oh no. All right, they're not really equal, nor could they be. I just threw out an entire point, didn't I? I just threw out like it wasn't even there. I just canceled it. They're really not equal to each other. And I continue to put the equals, but I technically should put one of those little squiggly things. So here they are. Y equals x squared minus 1. Thank you. Keep correcting me because I'm not looking at my screen. Squared. Now let's see if I can get rid of that. I don't know if I can get rid of that thing. I have no idea what's happening. Okay.
There we go.
Maybe that's right. All right. Over x plus 1.
Yeah.
All right. And y equals x plus 1. Oh no, I think I still have something funny up there. Might just clear the whole thing out. I don't know. That looks pretty good. All right. And then x minus 1. All right, so I guess I'm on probably a standard viewing window. There's one, there's the other, okay? Now I'm going to go to Zoom 8. Let's turn this one off. Okay. You've got to know what you're doing. I just made the calculator show me something that I already by my math knew was there. You gotta know what you're doing. You don't ever have to actually show yourself. I'm using this as a teaching tool right now. Please don't sit around for 15 minutes trying to get your calculator to show you the hole in the graph when table clearly tells you there's a hole in the graph.
I zoomed all because I knew there was a hole, and then I zoomed all the way in and there was no hole. And I was
Yeah,
like,
there
"Okay,
is.
there's a
It
hole
just
anyway."
all depends on where you're telling your computer, how you're lining up your pixels. It has to land right on that dot. Ours are by default, if you hit trace and follow, it counts by like 0.212 because of how the screen's divided up. I'm not getting heavy in technology, but I'm explaining it a little bit. So actually your trace button and your graphing screen is not counting by integers at all. It's counting by weird decimals like 0.212, 0.41. So yours you never set your window to where it would land right on -1. So it wasn't getting a hole because it never filled that correctly in, but it will in table. Table tells you error. All right, so watch this, girls. That's the blue one, and here comes the red one. Again, I'm using this as a teaching tool. This is not all stuff that you've got to be able to do. Whoa, I don't even want to be in there. I can't do it either.
Oh,
Okay.
I think use the arrows on the side.
These arrows?
Yeah.
I'm used to an older calculator. Thank you. That's exactly what I want. Now, do I just hit enter? Okay. All right, so here it comes. Thank you so much.
Oh.
Are they the same?
No.
They're exactly the same except for where. And one point. I didn't give you the second one. The second one is a prototype for the first one. Y'all see what I mean? Okay. So you've got to show me the hole in the graph. Let me continue on. I think up to 1125. Okay, so now we run into something new. Does this have a horizontal asymptote? No. It does not have a horizontal asymptote because what is this reduced to?
X.
Y equals X. And didn't it sort of follow Y equals X? But it wasn't quite Y equals X. We've got to be a little bit clearer. So I'm going to do long division. Okay? To find a slant asymptote, you do long division. It's not so bad. I used to hate it. You're not going to really care. Inside the house, you put x squared plus 0x minus 1. Outside, you put x plus 1. Hopefully you remember from your algebra and from middle school that if you don't have a coefficient of something, you've got to account for it. You have to have an x squared, an x to the first, and a constant in your dividend and your divisor. So if you have x cubed plus 3, you've got to have x cubed, 0x squared, 0x, and a 3. All right, now how many times will x go into x squared? What do I need to multiply by? Or x. And then you distribute it, x plus 1 times x. So I'm multiplying this times this, just like when I'm doing numerical division. That gives me x squared plus x. Then what do you do in long division? You subtract. I like to actually draw my little minus signs. It helps me, so I'm subtracting. Okay? These cancel. And what comes down here is negative x. Then in long division, what do?
You drag down the next.
Drag down the next thing, and then match it up again. What are you going to multiply by? Negative 1. When I distribute, this gives me negative x minus 1. When I subtract, what's minus and negative? Do you see those are both turned into positives? And my remainder is 0. That's unfortunate. Oh, I think they're going by. Okay, so here's a big deal. Usually you'll get a remainder, which means here's a slant asymptote. Follow me out the door, down to Madison, around to 83rd Street kind of thing. Okay, you're talking, I'm going to be quiet, whatever. You usually get a remainder and it'll follow the asymptote, okay? If you don't get a remainder, that means it's going to be OCD, all right? It's going to be, I am going to be right on the asymptote. Like, whenever I give, like, I don't give any crafts in here, but if I ever give you, like, something to fold or cut, I start to notice who's like this. They're right on the dotted line. Or if you're trying to draw, Greg, you're like me. I think like you're just like, it's gonna be good, okay? Because I'll get stuck if I try to make my little axis go right on that line, and I watch girls like,
Oh yeah, that is me.
there you go. Okay, so that's what just happens here. It's like I'm gonna do exactly what you told me to do. Okay, except for where can it not behave? This is the perfect child, except for it cannot behave at -1 because this is the original graph. All right, so how do you know where the hole is? There's two ways you can know where the hole is. One way is you can go to table like we did in our first investigation. Listen up, girls. Table's not very helpful because if you fill in -1, it's going to say error, right? But couldn't you fill in -0.9999? Let me show you real quickly. Keeping an eye on the time.
Wait, but if you plug in -1 you get error, then that's how you know the hole is there, right?
Well, it's either a hole or a vertical asymptote. Watch. I'm going to table. All right. I can't fill in -1. There's a hole in the blue graph. Okay. And just ignore the red for a minute. I'm going to then fill in -0.999. Okay. Do you see how I'm getting really close to -1? Because I'm going like this. Okay. I guess I'll poke a hole in my shirt the next class. I'm trying to destroy this one. So whatever. If this is a vertical asymptote, when I get really close to -1, it'll pull me off to infinity, won't it? If it's a vertical asymptote, I'll go off to infinity. But when I hit enter, I get -1.999. So the closer I get to -1, you see the closer this is getting to -2. The other way you can do it is this. Be the last thing that I say. Make sure I give you a worksheet, and I got to tell you one more thing, or just make sure you read announcements. Anyway, one other thing you could do is you could fill -1 into this leftover part. Fill -1 into the leftover part, you get -2. Remember that what just happened is you threw -1 away, and so you know that this is going to capture the missing point. So you can factor and cancel, fill in the number, the question into what's left over, and it'll tell you where you shouldn't go, which is -2. So here's my slant asymptote. This is my slant asymptote. I know I need to do some more with you, okay? And now I would usually draw my graph like, you know, stuff like that, like kind of crazy looking stuff. But this is going to follow it, except for at 1, -2. And I actually, in my hurry, was trying to draw a little hole there. Don't draw a blob, just draw a little like, that should be open. Okay? All right, let me tell you real quickly, as you're packing up and starting to go to chapel, or your lunch break. Yeah, I got you. I will, at this point, you'll get like your first video. I'll do some more examples for you. It won't last too long. Someone said I sent you guys a number of this. I'll do a few more examples of student asymptotes. And then your worksheet to get ready. Tuesday. So sometime today or tonight or this weekend, I'll send the video out via email with a link to it, and then I would wait and watch that. A little extra for me, and then do the worksheet. Okay. Also, yes. I'm probably not going to assign the entire worksheet, so double check where. Assignments. Okay?